Now we got autonomous system, an autonomous system, OSPF's autonomous system. This is what I'm going to use to teach all 4 types of stub. If you recall all that you learned this morning, it's the previous session, it will be easy to finish this lab. So I'll also help you to recall, do kind of revision before we do each type. So even those who come for the second session, no need to worry. All right. I'll show you what we have on R4. On R4, show IP protocol, I have EIGRP 10 and also OSPF. And I'm redistributing EIGRP 10, which means router 4 is an ASBR. This EIGRP autonomous system is an internet for us. This internet is also available via 7. Let's go and check 7. Show IP route EIGRP, you see. So these networks, 17 networks, are available. So we got this internet. See, the 17 network is like internet for us. It is available in router 7. Internet is available in router 7 as well as on router 4. You see, in 4 also, we do redistribution from EIGRP to OSPF, show IP route. EIGRP, sorry, I think I have shut down the interface. Let me bring the interface up. Interface G3/0. Now shut down. Now only interface is coming up. So I'm expecting EIGRP neighborship and then I'll give you the routes. Let me also go and check whether this interface is up. Yeah, I'll show you. Show IP interface brief. Here, this 48 interface is down, you see, G4/0 is down. I'm bringing the interface up. Right. So we got this link up. I'm expecting neighbor between 4 and 8, you see. With 8, we got neighbor on router 4. I'm showing you this. So when I type show IP route EIGRP, I should be learning these routes, which is also available on 7. You see? Compare. Yeah. So you got some additional routes as well. You've got some 78 network. Anyway, now what is next? I got 2 ISP connections. One in area 0 connected to router 4. Another one in area 100 connected to router 7. Let me show you the redistribution part on R7 and then R4. On R7, if you see, show run section router OSPF. I'm taking that EIGRP. Wait, I want to do some changes. I don't want metric type 1 now. I'll cancel this and do the redistribution again. Redistribute EIGRP10 subnets. If you don't put the subnet keyword, the subnetted network coming from EIGRP will not get advertised. Next. Let me check in R4, show run section router OSPF. Yeah, here there's a mistake then. You need to say redistribute EIGRP subnets. It's not given. So I'll remove this. Redistribute EIGRP10 subnets. Done. Okay, we got the external routes into OSPF. How do we verify this? See, I told you type 5 will originate from that same router from where it is redistributed. Show IP OSPF database. You can see type 5 here, local. All these are type 5 LSAs. Your own advertising router is 44444. Now, you don't see type 4 because this router itself is an ASPR. Same thing on R7. Show IP OSPF database. You have this is stub already configured. Let me go and remove the stub. Show run section router OSPF. Not just a area is already there. Let me remove it. Just ignore this, what I'm doing. Assume it is fresh. I need to do the same on R6 and R5. I use the same topology in other patches. I have to do the same on R5. Okay, good. There is no stub here. Fine. See, when we go to router 7 and check show IP OSPF database, you can see type 5 here. Type 5. And type 5 is coming from two different places. One is local, the other one is router 4, isn't it? There are two ISPs. So this network, you see, it is repeatedly shown twice because it is from two different sources. Well, let's go now to router 1 and start stub, the first type. Show IP route. You can see IA. IA means other area routes, isn't it? 4444, 5555, 6666. Is this same area? No. These are the loopback interface address of router 4, 5, 6, and 7, which are in other area. Router 1 is in area 50, 4 is in area 0, 6 is in area, 6 and 7 is in area 100. That is why IA means type 3 LSAs are IA. Even here down you see 10.34, 10.45, 10.46. These are all area 0, area 100 networks. You can easily see that here in database, show IP OSPF database. You can see here summary LSA type 3 for 50 area. These are the other area routes. Type 3 summary LSA. This is type 4, which is bringing the router ID of ASBR. Router 4 and router 7 are the ASBR. And who is giving you this? Your ABR. Your ABR, router 3 only gives the location of ASBR, not router 5 giving you. Router 5 gives to router 4. Router 3 says, I am giving you. I am giving you. That this guy is one ASBR and this guy is another ASBR. Okay, but listen, router 1 is also learning these networks from two different sources, two ISPs, 4 and 7. Let us check the routing table. Show IP route OSPF. It is using, even though the database shows 2, it cannot go via 2 because it has to first go to router 2. So you won't see two routes here. Database says I have two sources. I can go out via router 7 as well as router 4 to reach internet. But it has to go to router 2 first. That's why you see next hop is 2. Now my question to you is, I want you to really answer this. Why it is showing 2 ASBR? Why it is showing 2 ASBR? See, this R4 is the nearest ASBR, no? Why it is showing 2 ASBR? Answer please. No. We have not configured any stub as of now. My question is, the cost to reach router 4, the cost to reach router 7, they are not same. For R1, to reach router 4 is cheaper than reaching 7. Why it is not filtering router 7 in the database? Why in database I see both 7 and 4 as if they are equal cost? Are they equal cost? Reaching 7 and going to EIGRP is very costly than going via 4 to EIGRP. Why is it showing two paths in the database? See, now we have not configured any variants. We have not configured any variants. See, I agree. This is the default behavior, but why? See, if you say default, then it is configurable. You can change. If I need to change this, where should I change? Right now, it is showing both 4 and 7. I agree. It's a default behavior. Because of what it is, you call it as default behavior. Then if I don't want 7, If I want R1 to know that R4 is the nearest, ignore 7, what should I do? You're right. Something is default, because of that it shows like this. No problem. Arul, Sai? I told you, when you redistribute, the default cost is 20. So when router 7 injected the root, it is putting cost 20. When router 4 injected the root, it injected with cost 20. And path cost is not added if it is E2, which is default. E2, path cost won't be added. Have we discussed this? E1, E2? Oh, sorry. Okay, now I'm going to explain. See, E2 means external type 2, external network type 2, which is default. Path cost is 20. So according to OSPF, route given by 7 and route given by 4 is equal. Listen, when EHRP is redistributed here, the cost is 20. When it is redistributed here, the cost is 20. And the link between R1 and R4 is 1, 2, 3 links only. But the link between R1 and R7 is 4, 5, 6 links. But the problem is, by default, the path cost won't be added. That is what called as E2, external type 2. So this route coming here is also coming as 20. This route coming here is also coming as 20. That's why router 1 see both as equal. So if you change this type as E1 while redistributing, this will receive as 20 plus 3. 1, 2, 3 link, 23. The route coming from router 4 will be 23. The route coming from router 7 will be 20. 26. 20 plus the 6 links, 26. So router 1 will discard this. Not only router 1, router 2 will also discard routes coming from router 7. You're going to see that now. You see, I need to do the changes in the redistribution. I'll go to router 4 and router 7. Redistribute EHRP 1070. This is what we gave earlier. I'm going to say metric type 1. The default is 2. I repeat the same command on R7. Okay. Now if you go to router 1, you will not see 2. You will see only 1 in the database. Wait some time. Still shows 2. Wait some time. Sorry. Let me have a look on R3. R3 should show more clearly. Show IP OSPF database. There will be two database in R3 because it's an ABR. You see, in ABR you will have area 50 database and area 0 database. Area 0 database has ASPR, according to area 0 there are two RDRs designated route. If you go down in area 50 you got two designated routers, let's say, and three routers in area 50. Sorry. These are the routes that you get it from area 50. Sorry, from other area, type 3 LSA. Type 4 LSA will talk about the ABR. Now, wait. I see two routes, right? But in the routing table, this is what I want to show. In database, it's a link state routing protocol. It should show all the links, right? So in the database, you will not have any difference, but in the routing table, you're going to see show IP route OSPF. You'll see the cost difference. Earlier, it was simply 20. Now, when you see 23, what it is guaranteeing you, it guarantees that it has selected only the best path. It has selected only this 23, which is router 4 and 8. It has not taken 26. Yeah. So this is E1. E1 will have path costs calculated, and it will use only the path with the low cost because it can now calculate the path cost and it can compare the path with low cost. Earlier, it was E2, so it showed both the paths. But not in the routing table. If you would have traced the route, you would have seen one packet going to router 4 and another packet going to 7 when you trace. Now, if you trace, it will go only to router 4 and 8, straight to 8. It will never try to go as 6, 5, and 7. Anyway, coming back to our stub story, the main story. What did you say? No, 20 is the default cost when you redistribute in OSPF for external route. But while redistributing, you can say the default metric need to be 5 or 10. Say, for example, I'll go to 7 and say metric needs to be 5. So 5 plus 6 is 56. Sorry, 5 plus 6 is 11. Now we will see 11 on R1, which means it is going to go where out of 7. Sometime. Let's do this. One minute, I need to clear some space. It is past, I think. Let me go and tell it and make some space. I don't have enough space in my hard disk. So I have no other go to free it than deleting it. some videos. Okay, I think I freed the space. Yes. So I just changed the cast on R7 as 5. And if I go now, I should see 5 plus 6, which is 11. Still shows 23. Trace route. Network. 17, 16, 14, 1. Goes to 3. Okay, it is exiting via 4, not via 7. But I changed the cast. Let me go and check it on R6. There should be some impact, immediate impact on R6 because it's the very next router. Show IP route OSPF. I see 22 as a cost, which means this is also going via router 4. There's something wrong between R6 and R7. First, I need to troubleshoot that. Show IP OSPF neighbor. I do have a neighbor. Show IP OSPF database. Am I learning? Yes, of course I learned from 7. What is the problem? Why it is not using 7? Show IP route OSPF. So there is something wrong in between R6 and R7. I want to check. Show IP interface, show run. Maybe the previous lab, previous batch, I might have said something. Show run interface, some manual cost, something like that. I know. This is the reason. Okay, we'll come to this later. I am just removing this now. Because of this cost, it was not picking up. On R7 also I did the same. This part, if you don't understand, you can ignore because it's going to come later for you. I manually set cost higher to create some scenario. Okay, now if you go to R1 and check, you are seeing external as 11, as I said. Why? Because this guy is not saying, oh no, this guy is not saying 20, this guy is saying 5. 5 plus 6 is 11. Whereas this guy is saying 20 plus 3 is 23. So now if you trace route, it won't exit out on 4, it will exit on 7. See? Again, it's going by. Okay, you know why? The reason why it is exiting via 4 is, in 4 there is EIGRP directly connected, sitting there, saying, hey, why are you going to 5? I have EIGRP route. Administrative distance is 90. That's the catch. After coming to router 4, actually when it was starting from router 1, it did not know it is going to exit via router 4. It was thinking I'm going to exit via the path where there is 11 metric, which is 7. But when it goes to router 4, router 1 says, why sir, why are you going that far? I'm here, no. See, I'm here, no. EIGRP. Only administered distance 90. And OSPF is 100. Sorry, 110. OSPF is saying go to router 5. I am telling you 90. Come via G3/0. It went like this. Did you understand? Do you understand what I'm speaking? Please tell me. Did you understand why it is exiting via 4? Okay. We saw 11. 11 is the metric to reach which router? 4 or 7? Sorry? 7. Exiting via router 7 is what 11 is. If you want, I can prove again. On 7, I'm going to change the metric. Instead of 5, I'm going to say 10. So 10 plus 6 is going to be 16. So if you go now to R1 and check the routing table, it will say 16. Yeah, it is 16. It proves that according to R1, I am exiting via router 7. But to go to 7, it has to go through 4 only, no? So when you try to go on the path, router 4 says it went to router 4, but router 4 says, hold on, where are you going? 17, 16. Oh, 17, 16, 14, 1. Okay. Router 4 says, wait, let me show you some things. Show run. So show IP route 17, 16, 14, 1. It says, look, I have a better route via EIGRP10. Just exit via router 3. Sorry, interface 03. It says, I can take you. You don't need to follow OSPF. So this guy is controlling. Yeah, he's controlling it. And if I really want OSPF to be a decision maker, I need to go and change the administrative distance. So let me go here, router EIGRP10 distance. And I'm going to say distance as 115. Uh-uh. Yep, what is this? Okay, external is 175 as usual. Now, if you go and ask the router, it will show now. This distance is still 90. Okay, now it's changing. Now it says I'll go via OSPF. I'll go to router 5. Let us go to router 1 and trace route again. Look at this. So EIGRP in the middle, it was manipulating. It's no more. Did you understand what really went on? Yeah, I'm just asking all of you. Did you understand what was happening and what I did? How I made OSPF route to come? Did you understand all those things? It is not relevant to today's topic, but this is how networking. Yeah. Hmm? Yeah, I mean, I think rather than OSPF, is the it is because of administrative distance. Yeah. Mm. Mm. Yeah, yeah, you're right. So because of that, even though R1, R2 don't know anything about EIGRP, it used OSPF route and forwarded to router 4, but router 4 knows both EIGRP and OSPF, and router 4 was overriding OSPF decision. Though R1 says you will be going via router 5, 6, and 7, R4 said no, 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 no. You can exit here. So the packet was exiting out via router 4. But to make router 4 to follow the OSPF decision, we have increased the administrative distance. Fine. Now let us go back to the original story. When I check in R1, the routing table, I got a huge routing table. And if I check the space consumed, show IP route summary, I can see that OSPF has consumed 4,760, sorry, 752, 4,752 bytes of memory. And it has got 8 intra area, means type 3, 16 type 5, and 3 type 3. Inter area means what? Type 3 LSA. Type 3 LSA 3. You want to check that? I'll show you. Show IP OSPF database. You see? Same area 3 means type 1. I said type 3, not type 1. Same area 3. And then inter area. This is intra area, same area. Inter area 8. Let's see inter area 8. Is type 3. 1, 2, 3, 4, 5, 6, 7, 8. You have 8. This is type 3. And then type 5, 16 you should see. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. More. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This one you see. It is also coming from 4. Ignore that. Only one is taken. Only one is taken, not 2. So 48 and 17. The one with the cheaper cost is taken in the routing table. Don't take both. That is why it is 16. In the database you have 17 because you got 2 sources for that network. 78. 78 is also an external network which is between 7 and 8. This is also advertised in EHRP. Now, why did I show you those things? So that when I make this area as a stub area, the 16 routes will be removed from the routing table. Not only from the routing table, those 17 routes from the database, this will all disappear. Type 5 will disappear from here. Instead of all these, there will be one route added right before this 44444. Right above this 44444, a default route will be added. From this, what you understand, it is a type 3 given type 3 default route. It is given by ABR. That is what you should understand. It is given by ABR. Type 3. So, sub will filter type 5 and the ABR of that stub router will give a default route. Our ABR is 3333. Let's start configuring stub and verifying this what we learned now. Again, I'm repeating, there is somewhere around 4752 bytes consumed. I'll also show you in R2. Show IP route summary. Here, here it is too much. 7,000 is consumed. So let us verify on. We'll verify this on only router 2. So you'll have some better visual. 7,000, because this is a DR router. That's why it has got more size. R1 is a BDR. After configuring stub, see what happens. I have to configure the stub on all the router in this area, all the router, including this ABR. ABR also member of area 50, no? So, listen, I'm going to show you a very important thing. Before I start configuring stub, I need to capture traffic and keep it ready. Let me resume the video now. Okay, I don't know from when. So let me quickly make it short. Router 2 has got a big amount of memory consumed by OSPF. By blocking type 5, definitely this will go down. Even the routing table will go down, and the database type 5 LSA will disappear from this here. But still you will have a default route injected as type 3. That's what we are going to see. Now, what I'm trying to show you is when you configure a router as a stub, that router will start sending hello packet with the stub flag on. Stub flag will be on. That stub should match with neighbor hello, otherwise neighbor will not come up. In short, what I want to say is you have to enable stub on every single router in this area if you want this area to be stub. Not just on ABR. Why? Because the neighbors won't come if you don't configure stub on every router. The flag should match. See, like area ID should match to form neighbor, right? Likewise, you see. Area ID of router 1 is 50. Click on area router 2 and see, that is also 50. See, router ID 2 to do, area. Router 1, 50. If area ID don't match, they won't form neighbor. Likewise, if authentication don't match, they won't form neighbor. Likewise, see, authentication, null authentication. In router 2 also null authentication. It should match. When I configure stub on one router, you must configure on the other router, otherwise the hello packets won't match. Let me show you that. On R1, I'm going to say router OSPF 1. Area 50 is a stub route. You see, the neighbor will be going down. See, the neighbor has gone down. The reason is, go to router 1 now. Is this a recent paper? Okay, router 1. And I'll see stub mentioned somewhere. The stub flag. Here. Under the options, if you go down here, this is on. This one, sorry, this one. 0. External routing not capable. What is external routing? Type 5. Not capable. If you click on router 2, it is on here. It is capable. Let me repeat again. See, I click on router 1. Router 1. It is saying not capable because I configured it as stub. And when I click on router 2, it says it is capable. I'll just drag and do a filter for you. See, initially it was showing capable, but later only 2 has got capable. 1 is not having capability. Initially, if you go top, even 1 was capable because I did not configure stub initially. 1 was capable earlier. But now you couldn't see 1. Everywhere it is only 2. Because 1 is not capable. Let me show you 1. You will see only router 1. Only router 1. Because in router 1 only we have put stub. There is no router 2. Now router 1 is not capable of external, which is type 5 LSA. Likewise, you need to configure on router 2 to form neighbor. Router OSPF 1 area 50 is stub. Likewise, do it on router 3 also. Router OSPF 1 area 50 is stub. Okay. After this, they match, so they form neighbor. As a result, go back to router 2 and see. Earlier when we checked the size was somewhere around 7040 and there were 16 external route. I'm telling you, no external route now, and inter area will be 9, including the default route which will be given now. Let's check that. You see, there is no type 5. Do you see any type 5 here? No type 5. And type 3 has got a default route. Check the routing table. See, the size is considerably gone down, and there is no external routes. Before it was 8, now it has become 9 because of that one default route. Now you check the routing table, show IP route. You don't have E1 or E2 anywhere. Instead, you got a star default route injected by OSPF as type 3. IA means what? Type 3. You don't see any E1 or E2. Yeah. So a big difference, but still you can ping this EIGRP routes 17, 16, 14, 1. 17, 16, 14, 1. You'll be able to ping if you trace route 17, 16, 14, 1. It goes to 7 and exits. Why it goes to 7? Because we gave low cost there. Let's go and change that to defaults 20 plus the path cast. So I'll remove this. Now if I trace route, it should exit via router 4. On 7, then I need to remove this completely and put this. Okay, it exits via router 4. So we have learned first type of stub, which is simply stub, OSPF stub. It removes, it blocks, it is not allowing type 3 LSA coming in. Sorry, type 4 LSA coming in. It's not allowing type 4 LSA coming in. So as a result, you don't see show IP route, you don't see any OSPF external route. You don't see E2 routes or E1 routes. It will use this default route to go to gateway, and gateway is the one which is an ABR who knows E, means external. Only area 50 side is stub. Area 0 cannot be stub. I explained to you this in the morning session. Area 0 cannot be stub because it has got multiple ABRs. For area 0, there are 3 ABRs here. Router 4, router 5, and router 3. They're all connecting to, router 3 and router 5. They're all connecting to different areas. But it's a part of area 0. Area 0 ABRs. Now, let us continue. I'm going to make this as totally stub. The reason why I want to make it as totally stub is I do not want to have this IA. Coming from other area, I want to reduce my routing table size much more smaller. I want to have only the local routes in my area. I don't want the external routes. I want to have only the local networks in my routing table. And I'll use the default route to reach the external as well as the other area. If that is the case, then you need to configure the Cisco's total stub. I'm telling you something very important now. To configure total stub, no need to do any changes to R1 and R2. Already R1 and R2 has got stub configured. Keep that one, don't remove that. This is configured stub. Keep it, don't remove it. This is also configured as stub. Now you need to add one word, no type 3. What is type 3 called as summary? So no summary. When you add one keyword to the previous existing configuration, router 3, who is the reason for bringing type 3, will stop type 3. That is why you don't need to go and configure on all this router. Who is the reason for type 3 coming in? Is it router 2, router 1? No, it's only router 3. So you just configure on router 3 only this command, that is enough. Don't think, oh, it should match to form neighbor. No, only the stub thing should match to form neighbor. This need not do. So, clever design. I go to router 3 and I just add one word to this. I'll remove this and I add area 50. It's not simply stub. It is no sum. It means totally stub. See, the neighbor has come up. Now, if we go back to router 3 where we verify this, there is no IA anywhere. But you still have a default route given by, it will be there. You see, you still have a default route given by your ABR. So using this, you can ping other area also. You see, I can ping area 100, 6666. I can also ping the external. What is the external one? 17, 16, 14, 1. 17, 16, 14, 1. So I can ping both external and internal using the same default route. And you see the size of the routing table, it is very, very small now, 2992 only. There is no intra area other than the default route. Inter area. Inter area, there is no inter area. There is no external. That's why the size has gone down, gone down, gone down, gone down, gone down. Okay. What's next? We have learned two types of stub. Simply stub and totally stub. Now moving on to the third type. See, third type, you need this type of scenario. You should have two ISPs. One ISP is connected to area 0, another ISP is connected to area 100, so that you can make area 100 as not so stub area. When I configure area 100 as not so stubby area, I'll get default route to, sorry, I'll get type 5 for the external, sorry, I'll have type 5 blocked. I repeat again. When we configure this area as not so stub area, the type 5 that is coming from here will be blocked. 4 and 5 will be blocked. You're going to see that. But the local type 5, which is supposed to be type 5, because you configure as not so stubby area, it will start advertising as type 7. So instead of E1, you will see as N1. Same meaning, one means pathcast to be added. Let me show you that. First, let us see what condition is in right now. Router 6, show IP route OSPF. Look at this. They exit via router 7 and it is E1. But we are doing not so stubby area, assuming that it is exiting via router 5, which we don't like. We want to use the local exit instead of passing through our network. To go to internet, we want local exit, local ISP. So to simulate that, what I'm going to do is I'm going to go and set cost here. If I set high cost here, automatically R6 will go via this way. First, let me do that. Let me simulate that. See, only in this type of scenario, you need NSSA, where R6 is not exiting via 7 by default. So I go here, interface F0/1, IP OSPF cost 100. I increase the cost also on 7. Interface F0/0, IP OSPF cost 100. Now, if you go back to router 6, you will see earlier it was going via 7 to reach external, but now it will go via 5. See? No. External. Still it goes via 5 or 7. We need to wait for some time. The update will change. Show OSPF database. Oh, it learns only from 7. That's the reason. It learns only from 7. That's the reason. You know why? Because 5 is not giving. 5 is not giving the route which it just learned from 4. Is it learning really? Let me see. Router 5 should learn some external route. Oh no, it says the last update is on router 7. So router, I'm seeing router 4. I need to check in router 5. Router 5 is going via, this is also going via 6. Okay, is it because of, no. What is this? The cost is too high. Even the cost is too high, it is going via 6. Which means there is some reason, there is some problem between 4 and 5. 4 and 5, are you neighbor? Show IP OSPF neighbor. Are you a neighbor? Yes, of course. Show IP OSPF database. Do you have any information about the external network from? I know why. Because I changed the administrative distance of OSPF on R4. So I go and remove that administrative distance that I gave to solve this problem. Now, If I go now, I should see two routes, not 5, both from 7 and 4. Yeah, no, still I'm seeing only 7. Okay, now it has come 4 and 7. If you go now to router 6 will say, I'll go via 6 will say, I got both the informations, but I'll go via 5. Why? The cost via 5 will be cheaper. It's only 22. Whereas if you go this way, it is 100 plus. So we have simulated the environment which is really needed for NSSA. What is that? Router 6, instead of using its own local ISP connected via R7, instead of using R7, it is using R5 and R4 to exit, which you don't like because it is consuming your bandwidth, your router. When you have subscribed for internet, why can't this use this one and go exit like this? Why it is going inside? That's your. So you want to configure NSSA so that this type 5 will be denied coming in. So that even though the cost is high here, this will be preferred because this is denied. Right now it is coming, so R6 is using this. You see, show IP OSPF database. Right now it is coming from 4. Type 5 is coming in. But if I deny type 5, you will not see this. Let's see. You need to configure what I'm doing now on every router. So let me sniff the packet and show you. I want to sniff the packet and show you how it looks and what should match to form neighbor when I configure NSSA. Now if I click on 5 and see the OSPF header, in here if you see NSSA not supported now, and both on 5 and 6 it is not supported. I'm clicking 6, I'm clicking 5. Both it is not supported. This should match. This should match. 0x12 should be matching on both. But now I'm going to go to R5 to configure stub, or R6. I'm configuring stub first on R6, you see. It will lose the neighbor. Both 7 and 5 will break. Router OSPF 1. Area 100 is not so stub area. Boom. Now you will see neighbor going down. Both the neighbor went down. Now you see here in this, when I click on 6, it says NSSA is supported, and you see it changed here. 0x18, it's not 12. If I see, only 6 will be having that 18. But when I put 12, 5 earlier, 6 also was having, but now it's only 5. Only 5 is having 12 now. 6 earlier we had. The earlier packet it shows 30 and all earlier. See, nowadays it's now after 38 there is no, after the frame number 34 you don't get 6 10 5606 because I configured it as stub. Okay, now where are we? This is configured as a stub router. Router 6 is configured as a not so stub area router, not so stub area router. And as a result, the Wireshark is showing this has got support for NSSA, whereas 5 is saying not supported. Let me go to router 5. and configure the same command. Router OSPF 1 area 100 is not so stub area. Do the same on R7. Router OSPF 1 area 100 is not so stub area. Boom. As a result, the neighborship will come in between all these routers in area 100 and you'll start seeing the magic. Let's go to router 6. Show IP OSPF database. You see, instead of type 5, you see only type 7. And it is pointing towards router 7 only. As a result, if you check the routing table, show IP route show IP route OSPF, you'll see N1. N1 and cost is 100 plus 100 is the link cost, 20 is the default cost. And one is because of the loopback, something like that. 121. Even though the cost is higher, it goes via that one because there is no type 5 coming in. There is no type 5. So if it trace route, it will go only to router 7, 17, 16, 14, 1. Goes via 7, exiting via 7. Let's go to router 5 and check the same. Router 5 is a member of both area 0 and area 100. So router 5 will exit via area 0 only. Show IP route. It exits via router 4, you see, because it's a member of area 0. Router 5 will have two database, I told you. Area 0 database will have type 5. See, show IP OSPF database. Area 0 database will have see, this is area 0 database. No area is mentioned, which is area 0, type 5. Whereas area 100 will not have type 5, instead it will have type 7. The same advertisement which you saw down here as type 5 in area 0 is seen here as type 7. Because this router is a member of both area 0 and area 100. Area 100 is an SSA. So you understood why we need an SSA. Now we are going to the final one, total NSSA. What it will do, it will block type 3 coming in. To verify, I will take you to router 6. Show IP OSPF database. Please focus here. Just last topic. These things will be removed. Instead, a default route will be given. So the size of the routing table will be really small. You see, show IP route summary. Right now, size is 7,000. See what happens when I make totally not so stub area. You know very well the type 3 is given by R5. So you go only to R5. Router OSPF 1. Earlier we said not so stub area. Now you add no summary to it. That's it. That's all. You just add no summary to it. That's all. Yep. As a result, if you go back to router 6, earlier it was 7040, but now you see 7216. Because type 3 was very small actually, Type 3, if you see earlier, type 3 LSA coming from other area was 22 earlier. When it was 7,000, it was 22. But now, type 3 is only one, a default route. It is just only one now. So, routing table, if you check show IP route, you will see only one IA, which is a default route. Only one IA, which is a default route, and then you have N, and then you have local O. O and N only you see. You see O and N1. You don't see IA because type 3 is denied, but still you can ping. Listen, you can ping 2222, which is other area, even though you don't have root. See, show IP route 2222, you don't have root. You don't have root. What is this? What is this? Oh, it goes and enters like this. Like this, it goes. Come on. Why you should go like this? Use a default route. I have given you default route. Show IP route. Okay, there is a precise route via N1. That is why. Even the external network also somehow I made some mistake. Yeah. I redistributed OSPF into EAGRP. No, so that EAGRP is redistributed into OSPF here. That is why I redistribute OSPF into EAGRP. I need to cut that one here on R4. Then it will stop. R4. Show run section router EIGRP. I need to cancel that redistribution. You see this the one OSPF. I'm putting under EIGRP.